All right, so chapter 4 will cover data mining for business intelligence. We're going to go to chapter 4 and then chapter 5 later on after a couple of weeks. And then the last chapter we'll do is chapter 3. So we're going to skip ahead. Okay, so the first slide goes over data mining concepts and definitions, why data mining. And Thomas Davenport said analytical decision making is a strategic weapon for companies, and it actually has become pretty true. Many companies want you to know how to analyze data, and they want you to be able to make decisions using information that you've gotten from data analysis. There's more intense competition on the global scale. There's more and more information available. You know, a lot more time goes into analyzing data than it used to. Now, that's in terms of managers. Used to be data was analyzed manually, so it took a long time, usually a lot of people. Now it can be done, managers can do it themselves at their desk. They can pull a whole lot of data from this data warehouse, and they can analyze it using software. So the storage capabilities have increased, the cost has decreased, so it's become more popular, and then it's also almost essential now to compete in the industry. You have to know what your competitors are doing, and you have to know how you're doing. Okay. So what is data mining? Data mining is basically mining for knowledge in large amounts of data. You're identifying valid, novel, potentially useful, and ultimately understandable patterns. So basically the data, the process is iterative, meaning there's many repeating steps. But basically your data is non-trivial, it's valid, it needs to be novel, meaning it's not something you already could have guessed, and then potentially useful and understandable. And non-trivial and understandable kind of go together. If it's trivial, it's not going to really be understandable or even useful. Yeah, useful and non-trivial go together. If it's not useful, then it's pretty much trivial. And those definitions are all in the notes. Let me go back. Yeah, they're all down here in the notes if you want to read through them. Okay, so this chart kind of shows you that data mining is at the center of many different disciplines, so it's not a new concept. It's basically a new name for the use of all these disciplines together. So you're using artificial intelligence, you're using statistics, you're using modeling, databases, pattern recognition, MIS systems. All of these you're using together to mine for information. And so, as the book said here, the miner is often an end user empowered by data drills and other powerful query tools. And they can obtain answers quickly with little or no programming skills. It used to be in order to query the database, you had to know SQL. Now it's more user interfaces and you type in what you want to know. So characteristics of data mining. It's often a consolidated data warehouse, not always. It's usually client-server or web-based. So you either have a client PC accessing the server, or you have a web-based system. Miner's often the end user, and ease of use is essential. Okay, so this portion you may have seen before if you've taken business analysis. Data in data mining. Data is either categorical or numerical. Categorical data is either nominal or ordinal. Numerical data is either an interval or a ratio. And these are important to know when you're going to analyze the data, because many software programs will ask you. And the data is analyzed differently based on the type of data it is. So that's where a lot of this it'll make more sense when you're doing it. It's good to learn it now, to have the basis, but once we go into SAP, things will make a lot more sense then. It'll be kind of like, oh, I get it now. That kind of moment when you do it and realize that's what that meant. And data consists of numbers, words, images. Data nowadays can be anything from pictures to just numbers. Okay, and I'm going to go into these. Categorical data. It's basically can be categorized. You can either put it in groups or categories. Race, sex, age group. So it's not, see, numerical data can be measured. Categorical data can be categorized. That's the difference between those two. Now within categorical data, you have nominal and ordinal data. Nominal data cannot be ranked. Ordinal data can be ranked. Such as you have freshman, sophomore, junior, senior. That's a ranking system. Low, medium, high. Where single, married, divorced, that's not a rank. You know, divorced is not better than married, or is not higher level than married. You might have first, second, third, that's a ranking. These can make the most sense, but when you're going to actually look at data, sometimes these can be the hardest to differentiate between nominal or ordinal. So you have to pay close attention to the differences. Okay, so again, numerical data can be measured. Age, number of children, you know, age, you could take current date minus year is your age. That's a measurement. The interval scale, interval data can be measured on the interval scale. All you have to remember is interval data has an arbitrary 0. That means 0 does not mean an absence of something. 0 just means 0. Taking, for instance, 0 degrees Fahrenheit. That does not mean there's no temperature. There's a temperature. It's just that the temperature is 0. With ratio, 0 means you don't have something there. You have $0 in the bank. You don't have any dollars. It doesn't mean there's a $0 sitting there. There's nothing. But if it's 0 degrees outside, it's 0 degrees outside. So that's the easiest way. Now with these, I know in stats we're supposed to memorize these. Most of us memorized what categorical and numerical were, and then just remembered one of these. Because if you know one, you know the other. If you know ordinal can be ranked, you know nominal can't be. If you know ratio has a 0, that means there's something missing, then you know interval has a 0 where there's not, the absence of something. So that's a good technique to remember those two. Okay. So what does data mining do? It looks for patterns in data. You might look for a certain number of people, like maybe you're going through the data. One data I had to analyze was the Career and Testing Center at Lamar. And I had to go through the data and I would mark everything. You know, which advisor they saw, what they came in for, what college they came from, what their major was. And then I organized everything. And what we came up with was charts and graphs that told us patterns. So we were able to see, hey, we have a higher percentage of engineering students coming in. We have a higher percentage of business students coming in. Well, those are the ones we market to the most. So there's a pattern between them. There's also a pattern between one advisor has more visitors than others, so maybe that advisor is more popular. But the software systems are going to help you to do it on a much bigger scale and much more quickly and with a lot less time. I mean, it would take me hours to analyze that data. This is going to do a lot of it for you, but you have to be able to understand it, to be able to read it, and to be able to know what you're looking for. Okay. Now, data mining has three main categories. There's prediction, there's association, and there's clustering. On a more technical note, learning algorithms of data mining methods can be classified as either supervised or unsupervised. Just know that supervised means descriptive and class attributes are included. Unsupervised means that just descriptive attributes are included. And that has to do with how the data is mined or analyzed. Well, we won't get that technical because this isn't a database class. But just kind of understand what those mean and that these are the three types of data mining. Okay, with prediction, that's where you're pretty much predicting something. But predicting is not guessing. Predicting is where you're taking into account your experiences, opinions, and other relevant information to foretell. Forecasting, on the other hand, uses data and models to forecast. So prediction, you're going to use information and try to kind of not guess, but kind of guesstimate, kind of foretell what might happen. You know, you may I've worked in the industry for a long time, and you kind of know how things work. Like a lot of predictions occur in the fashion industry. They do use forecasting as well, but there's a lot of prediction based on knowledge of fashion, knowledge of the industry. You know, a lot of times they can predict what's going to be in the next season. Forecasting is going to mean more data and numbers. Like when you forecast what the temperature is going to be tomorrow, you're using big model systems, data, numbers. Classification, that might be more prediction, where you're saying it's going to be rainy tomorrow, it's going to be sunny. But it could also be forecasting. But forecasting can get more specific into the actual temperatures. So these are types of predictions. Okay. Now clustering, that's where you're grouping things based on similar characteristics. So you might have customers in a region, maybe you own a gym, and you're grouping them based on whether they have a gym membership already or not. So you're going to market to those who have a gym membership differently than you market to those who don't. You know, you might offer them special deals for switching, special new sign-on bonuses. If they don't have one, you might offer them new membership deals, maybe tips on why you should be working out, maybe you might take into consideration why they don't have a gym membership, like maybe how far away it is, whether they have kids. You might mention you have a daycare. All of these things are going to affect how you market those customers. So you're going to cluster based on characteristics. And you can do these manually, or there are systems that will kind of cluster things based on the characteristics. And the goal is to create groups so that members within each group have maximum similarity. So kind of like you may have the gym, non-gym members, gym members, and then within the gym members you may have those with kids, those who live far away, things like that. Associations, basically you're looking for groupings, such as when someone buys diapers, they often buy beer. You might suddenly notice that grouping. If you have kids and if you drink beer, that might make sense. You know, maybe I can think of a few other things, but maybe, you know, chocolates and flowers. Someone's going on a date. You could probably think of several different groupings where people buy things together. That's where they came up with the idea to do plane, rental car, and hotel together. You can get a special deal for buying all three because many people who travel buy all three. So the link analysis, it's automatically discovered the linkage, where with sequence mining, You're going to identify associations over time. And then it's often called a market basket analysis, the association analysis, because a lot of times association analysis, they're used in large-scale transaction recording systems, point-of-sale systems, such as when you use your Kroger card at Kroger. Okay, so other data mining tasks. You have time series forecasting and visualization. Time series forecasting, yeah, it's data that's stored and captured over time, so you can see how it changes over time. A good analysis is if you look at stock prices, they have years and years back where you can see how they've changed over time and see similarities and maybe see different years and what things affected it. Maybe try to figure out a pattern. No, with stocks, it's a little more, can be a little more erratic based on extenuating circumstances, you know, stock market crashes. Visualization, that's making things make more sense by having a visual view of it. Now there's two types of data mining. You have hypothesis driven and you have discovery driven. Hypothesis testing you'll do in statistics. That's where you have a hypothesis and you're trying to validate it. Or you may invalidate it. Discovery-driven data mining, that's where you're going to find patterns, associations, and relationships. So maybe something you didn't previously know was there and you're going to discover it. Or with hypothesis, you have a proposition and you want to prove it. Okay. So data mining applications, customer relationship management, it's where you want to create one-on-one relationships with your customers. So you want to understand their needs and wants. And these are all things that having that information can improve. You can maximize your return on marketing campaigns. You can better market to your customers. You can identify your valued customers and treat them better, maybe offer them special benefits. Maybe you see something someone buys a lot, make sure you send them a catalog at the time of year they buy it. For instance, my mom always buys Tillamook beef jerky because we are from there originally. She buys it every Christmas. So every Christmas they email her and tell her, hey, you want to buy more beef jerky? Stuff like that. Banking, you can automate loan applications, maximize customer value, detect fraudulent transactions. You know, it might flag if someone's suddenly using their card in China. And then again, some more ways it can improve processes. These are two areas that it's highly used, especially in medicine, because you're looking for patterns, maybe in survivability for cancer patients, symptoms and illness similarities, organ transplant success rates. You might put in factors and find certain factors affect whether the transplant is accepted or not. And then you can put in certain factors to find out why maybe some people certain medicine doesn't work and it works on others. And there's the book has quite a few other examples. I think it's on page 146 and 147 if you want to look through those. All right, so data mining software. The most popular tools that are developed by the largest statistical tool vendors, you have SPSS, you have SAS, you have IBM, and you have StatSoft. There's more, but these are the largest. Business intelligence vendors, SAP Business Objects, Teradata, they'll have a level of data mining integrated, but they're not considered as direct competitors for data mining tools because they focus on multidimensional modeling. So they focus on analyzing the data as opposed to, you know, pulling the data. So Weka is the most popular open source. It has a large number of algorithms and an intuitive user interface. RapidMiner is it's a newer software. It's more graphically enhanced. But the difference between commercial and free is that free software will not run as well on large amounts of data. It may not run at all. Commercial software is going to handle large amounts of data better. All right. And this is an example of a churn analysis in Microsoft SQL Server 2008. Churn analysis is a calculation of the rate of attrition in the customer base. So how well you're keeping your customers. Actually, I think that's retention. Attrition is how well you're obtaining customers and keeping them. So it kind of has to do with retention as well. So it's SQL Server, actually it's supposed to be server. 2008 BI Development Suite. And it has data models that are stored in relational database environments, so it makes management of the data and the model easier because you're only accessing one relational database environment. But again, a lot of this will make more sense when we actually go in and start doing the processes. We won't use SQL, but we'll use SAP. But it's good to have the background now so that when you go in to do the work, you know, it'll make more sense. So that's it for chapter 4. You'll have an assignment for this week, and then you'll have an assignment for next week. And I think you have a video or a session to listen to as well.